It's really nice to be back in Amsterdam. The first time I was here at GOTO Amsterdam was about my third ever presentation, so I was insanely nervous. And now I'm not insanely nervous, but I probably should be, frankly. Hello, I'm Trisha. I work for JetBrains. I'm the advocate for IntelliJ IDEA and UpSource, and what that kind of means is that I have to stay up to date with what's happening in the Java world. Particularly, obviously, the big news at the moment is Java 9. So my job today is to try and look at how the Java 9 features will impact us as Java developers and which ones we might actually use in real life. So we're going to go over Jigsaw in action. So I didn't want to talk about Jigsaw because everyone is going to be talking about Jigsaw all year this year for Java 9. And it's like the big ticket item. And don't tell anyone, but I don't think it's very exciting. So I really didn't want to talk about Jigsaw. But I did try it out. So I do want to talk about the pain of using modularity in Java. Who knows about Jigsaw so far? Anyone? A bunch of you, that's good. I'm just checking. You are Java programmers-ish, right? Good, excellent. Who's using Java 8? Oh my God, that's like all of you. This is really good. You're exactly the right audience for this talk. So I will talk about Jigsaw, even though I really didn't want to, so we will go over that. The original goal of this presentation was to talk about reactive programming in Java 9. The reason being that the Reactive Streams API is embedded in the language in Java 9. So I wanted to do this big reactive programming thing. But it turns out there's so many features in Java 9, there's just not a lot of time for all of that. So we'll skim over what that looks like, but we won't go into it in a lot of detail. And then we'll talk about all of the other stuff in Java 9. No, not all of it, just the bits that are interesting. So if you do decide to migrate to Java 9, don't do that just yet, but if you do want to, then you're going to need some arguments as to why use Java 9. Now, the Oracle guys in particular have been working very hard, as usual, on the latest version of Java, so it's not just about adding modularity. There's loads of free stuff, like better performance, better use of the CPU, better documentation, better graphics, blah, blah, blah. So even if you don't use any of the Java 9 features, you will get improvements, probably, if you use Java 9. The slides will be available afterwards, so this talk never ever comes in at 50 minutes. So I'm going to talk really fast, I apologize, and skip over a bunch of slides, so if you're interested in the detail, you can look at the slides afterwards. And of course, Jigsaw is part of Java 9. You may have heard of the REPL. Who's heard of the REPL in Java 9? Loads of you. Who has heard of a REPL generally, or used one? Okay, so the REPL, for us as Java developers, I think the REPL is a very new idea. So it allows us to try out things from the command line. So we can type like a single line of code and have it execute, which for Java is very exciting. You don't have to have a whole class with public static void main or any of that nonsense. You don't have to create entire test files just to create like a little tiny trial snippet of code. So you can do that from the REPL. And the REPL is going to be part of Java 9. We're not going to cover a lot of that because that's kind of a big topic in its own right as well. So if you think about Java 9, you hear about Jigsaw, you hear about the REPL maybe, and you don't really know if there's anything else in Java 9 that's particularly exciting for us as Java developers. But it turns out there's just one or two other features that went into Java 9. It's just a couple. Some of these you won't see. There's a lot of stuff under the covers. I mentioned some of the performance improvements. There's things like they wrote performance tests for the JDK itself, and there's a lot of infrastructural stuff that went on that doesn't necessarily, they're not features that we'll use, but they will hopefully impact us in terms of a better JDK, a better JVM. But there are things in here that we won't have heard of, small features, that I do want to cover in this talk. I always like to set the expectations appropriately low, so do not put Java 9 into production. It's not ready yet. It's not out yet. Recently, they were saying it was going to be out in July. Now they're proposing September. So it's not out yet. However, you can try out the EA version of it, which I do highly recommend, but it is evolving, and it's still evolving to the extent that even the APIs are still changing. So each EA will behave slightly differently. I've just updated this demo from build 166, which I used earlier on this year, to build 173, and there are changes in those builds. And the other early access thing is IntelliJ IDEA, so I'm using IntelliJ IDEA 2017.2 EAP, which is, as always with EAPs, an interesting experience, and sometimes crashes horribly. So like I say, setting expectations appropriately low, but the 2017.2 EAP has a bunch of Jigsaw features which I really want to demo, so I have to use all the early access things to kind of show you this stuff. The case study. You may or may not have seen an earlier presentation I did was called Java 8 in Anger, and I wrote, this is like a JavaFX UI, which I'll see if I can show it to you. And it kind of reacts in real time to like Twitter messages. It says like how happy or sad they are, who's doing the most tweets, and stuff like that. And this was designed to show off the Java 8 features. So there's like streams and Lambdas and stuff. Oh no. Blah, 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 blah. And what I wanted to do was use this, because it's a real piece of code. It's kind of demo code, but it's a real piece of code. And I wanted to see how much pain it was to migrate it towards Java 9, what the advantages might be. So we're going to use this code base and try and use some of the Java 9 features in it. The other good thing about it is it's a kind of, well, I wouldn't say microservice architecture because it doesn't have good microservices stuff like, reliability. But it does have independent services which were designed to pass messages between them. So this architecture works quite nicely for the reactive paradigm. So that's another reason why I wanted to use this case study. If you're interested in the original case study, then go away and look at the video of that. I'm not going to do any of the background on this at all, so because it's just a waste of time. There's loads of videos on that already. As I said, I'm going to go quite quickly. I apologize. First up, compiling with Java 9. If you've heard anything about Java 9, it's probably that everything's going to break. That's not strictly true, but there are a lot of changes which may impact your code. So the first thing I wanted to do was compile my Java 8 application in Java 9 and see what breaks. So let's go ahead and do that. Okay, so let's switch to an appropriate branch which is my original code. So this is if I compile this, rebuild the whole project. This is my original Java 8 code building on build 173 of Java 9. Let's put this into presentation mode so you can see it properly. Right. So the first error we get is that as of release 9, underscore as a keyword may not be used as an identifier. So this is something I did sneak in to show an error. I didn't really have something which is called underscore. It turns out, honestly, I promise, it turns out that underscore was a perfectly valid variable field parameter name. And it's not going to be going forward, but now everyone knows that it's a valid field name. People are like, oh, that's quite interesting, I could use that. It's going away, don't use it. So that's an easy fix. Something useful. Just rename it to something else. But if you are using underscores, it won't work anymore. In Java 8, you'll get a warning about that, so you should see that that's something you shouldn't be doing. OK, what else happens if I recompile? So this is the sort of thing that we will have heard about if we've read anything about Java 9, the encapsulation of internal APIs. So anything which is sun.misc, which we shouldn't have been using in the first place, but we did, because sometimes there wasn't an alternative. In this case, I genuinely was using this class in my Java 8 one because I was like, oh, that does what I want. I know I'm not supposed to use it, but it does what I want, so I'm going to use it anyway, which is what we all do. So you can't use that anymore. Basically, the compiler says it's not there. Now, it is there. It's just hidden away, so you can't access it anymore. So I need to get rid of that and replace it with whatever the replacement is. And in this case, it turns out it's fairly straightforward. I need base 64, java.util, get encoder, encode to string, rebuild, and everything will work. So generally speaking, if you're using sun.misc, which you shouldn't have been in the first place, you need to replace those. Anything which has a valid replacement in Java 8 or 9 is documented, so you can see what the replacement should be. There are a couple of exceptions which don't have replacements, most notably sun.misc.unsafe. So unsafe is a special case and has been it's been given leave to continue existing for the time being because there isn't a full replacement for unsafe. But you shouldn't be using unsafe if you don't know what you're doing anyway. That's what they say. So that's what I have to say. That's the official line. And when I did my last presentation here, I was talking about the disruptor, and the disruptor does use unsafe because it has to use unsafe, and that's the way it goes. Right, so compiling with Java 9, you may find there are some things which are broken, but probably not as broken as you expected. One of the things I wanted to recommend is that you drop the Java 9 JVM into your continuous integration environment and spin it up and see if it runs. And it turns out that lots of CI servers don't support Java 9 yet. So that might not work. So you might, yes, download it, give it a go, see what breaks. Jigsaw, let's talk a bit about Jigsaw, because, you know, everyone's going to be talking about Jigsaw. Now, this is my original project structure. It is modular. I was using Gradle plus IntelliJ to kind of split it into modules. I had this kind of microservice type architecture, so it lends itself to modular code. But it turns out that when I went back to it later to turn it into proper modular code, I hadn't done it right. Who knew? So what I had done in the original one is I had a module for my UI code, a module for my shared infrastructure code, and a module for everything else, all of my back-end services. And I didn't notice this was a problem, probably because I'm not responsible for deploying this code because it's demo code. Now, if I had to deploy it as small independent jars, I probably would have split it up differently. With Jigsaw, with the Java module system, you're forced to think about what you're going to deploy, which jars you're going to deploy, and how your code is modularized, like as a developer. That's something you have to think about, which is, I think, is kind of a good thing. So when I modularized my code, I ended up with a module for my UI code, a module for my shared infrastructure code, a module for another utility, and then all of my other services were independent modules. So it was actually more correct. So Jigsaw kind of forced me to think about this more correctly. So I did it wrong to begin with, but I didn't have anything to really tell me I was doing it wrong. Oh yes, and the other thing is that Gradle doesn't work in Java 9. They're working on it, and I keep pinging them every week saying, is it done yet? Is it done yet? Gradle doesn't work in Java 9. It will. They are working on it. The problem is that Java 9 has been moving so fast that Gradle were like, we're just going to wait for it to stabilize a little bit before we start trying to catch up. Maven does work. Gradle doesn't. So I had to rip Gradle out of my project. Groovy, at the time when I first wrote this in February, Groovy wasn't working with Java 9. I don't know if it is now, so I can't categorically state. So I stripped out all the Groovy tests as well, turned them into JUnit5 tests. And it turned out that, I mean, I really like Spock for testing, but what I noticed when I was using JUnit5 is that the tests run much quicker now, because I'm not using Groovy, which is sad, but true. So as well as restructuring my whole project, I also had to rip out Gradle to get it to work. I had to rip out Groovy to get it to work. And then I can jigsawize my code. So what this means is, oh, you can't see that very well, but you have a magic new file called module-info.java, and that defines the modules. It doesn't just define what the module looks like, it also tells things like IntelliJ IDEA that you're using the modular system, so you compile with module path instead of class path. And this is where all the magic happens. So the thing about Jigsaw, about modularity, that I hadn't really realized till I started doing my research is, when you use modularity, there's no such thing as a class path anymore. That was sort of part of the point, to try and get rid of this enormous monster and trying to treat code as separate individual modules. So when you start using module info files, you have to start using module path instead of class path. I'm not going to go into the details of that, but just be aware of that, because I didn't know that class path was like a thing of the past. It's a dinosaur, it's dead. But except that you can still use class path if you still want to use class path, and that's part of the noise around when do we release Java 9, what does Jigsaw look like, what are we allowed to do, what are we not allowed to do. Lots of people still want to use the class path, not surprisingly. The other thing is, so my structure here is I'm using a Gradle-style structure, which has got the module with a source directory and a test directory. And my test directory doesn't have a module file, because then I'd have split packages across two different modules. There is a way to fix that. I didn't do it for this demo, and I run the tests from inside the IDE, so it doesn't impact me that much. So moving to use a modular system was a non-trivial task for me. The suggestions from the demos and stuff from the Oracle guys is that your structure has a source directory at the top level, and your modules are inside your source, and then you have a test directory and modules inside that, which is what I did when I first migrated. But that's like, obviously, if I was using Gradle, it would completely freak out about that. So it's a totally different way of working. But you can do it the sort of more traditional Gradle Maven way, and it still works. It's fine. Right, so we're talking about architectural type stuff, so I thought I'd put some UML up here. I generated a diagram using IntelliJ, because I'm lazy. And what I wanted to do is, when I was starting to split my project into modules, I needed to understand my dependencies to figure out if I had things correct. And it turns out I don't have them correct, because I have my modular code from two different services depending upon code from another service, which isn't right. It can listen to messages from that service, but it shouldn't be reusing code from there. I have one jar file which is only used by one particular module, which made sense. It's no sense. It's an API which shouldn't have been being used. And I had a Reactive Streams jar file which was used by two different modules, which also made no sense. It should either be used by one or all of them. And so by actually mapping out my dependencies, I kind of figured out I'd designed my application in a slightly weird way. So I redesigned it. So all my services are now at the same level. They don't depend upon each other code-wise, which is the right thing. They depend upon my reusable infrastructure code, and they depend upon, and a utility as well. My backend services all depend upon this Reactive Streams utility, and two of my services care about one reactive implementation, and another one cares about a different reactive implementation. The idea here being that I'm using Reactive Streams API, so I don't care about the implementations in the independent services. So that's the dependencies diagram where we're talking about our IntelliJ modules and our jar files. This is not the same as a JDK module diagram. So if we look at one of these modules, the client, the UI module, let's look at what the module diagram looks like. So this is kind of quite a different way of looking at things. So my client uses JavaFX, so it's dependent upon a number of JavaFX modules from the JDK, specifically fxml, controls, and JavaFX.base. And you can see there all the dependencies inside there of all the modules they depend upon. So all those yellow ones are inside the JDK itself. Now the point about modularity is that you don't have to use the whole JDK. You just define which bits you want to use. So here I had to say I want to use these specific bits of JavaFX. And apparently that will have all of those other dependencies. My backend service module depends upon a jar file, which has not been modularized, so it doesn't look as pretty as the JDK dependencies. What happens when you're depending upon a jar file that hasn't been modularized is it gets turned into something called an automatic module. And this is something else that people are arguing over. What do automatic modules look like? What should the name be? How do they work? In this case, I'm dependent upon one jar file, which is the WebSocket server impl, and that translates to 3 different automatic modules because it's based upon package name. So it's just something to be aware of. Like, there's not a one-to-one mapping between the idea of a module and a jar, and the point here is that the JDK modules, there are lots of them, and you have to understand how they work. Also, this module diagram is new in IntelliJ IDEA 2017.2, so I kind of wanted to show it off as well. But it's quite useful when you're getting started with Jigsaw to understand the architecture. It's quite useful, obviously, to sort of draw this out to figure out what you've got, so you can see if it matches your expectations. So, given all of that preamble, which was supposed to take 5 minutes and didn't, let's look at what happens if we want to create a module info file. So let's look at this from a developer point of view and see how hard it really is. So I'm going to switch to the right branch. So what I've got here, I've got my different modules. Most of these have a module info already. I've got one module which doesn't have one, so we're going to create one for this module. Obviously, I'm going to make the IDE do it for me, because I'm really lazy. And once I start doing that, when I compile, as I mentioned before, the way the compiler works is now different. It's not dependent upon all the code on the class path. You have to start defining the modules that you care about. So if we have a look at this class, for example, come back. Previously, I was dependent upon Java util logger, and that was fine, and that worked, and it compiled. And now I've just added a single thing. I've added the module info file. Now that no longer compiles, and that sounds kind of weird. But it's because you need to specifically state that you're using the module java.logging. So if we add that, let me show you my module info. We have to say we require java.logging. By default, what we get, I don't have to say this, I'll just show you what it looks like. By default, we will get requires java.base. I don't have to say that. And java.base has things like java.util and most of the basic stuff that you use all the time. So you don't have to say you need that. But anything else outside of the base package, base module, you have to explicitly declare that you're dependent upon a different module. So in this case, java.logging. And the other thing I need is I'm using an external jar file. I'm using reactive streams. So I need to tell the module info file to sort of look for those modules, even though they're not real modules. So here, I say it requires reactive streams. If I drill through to that, there we go, it's loading up. That means it's using this jar file here. Okay, so the good thing is that IDE can do a lot of the heavy lifting for you. If you're not keen on the IDE doing heavy lifting for you, you can use a tool called JDEPs, which will analyze your dependencies, and it will tell you which modules you are depending on. And then you can basically copy-paste all those modules into your module info file, and then it should work. I believe you can use JDEPs to generate your module info file, but I couldn't get that to work last time I tried. I think that might be in a version that's not out yet. So let's rebuild. What's the other error we've got? Now, if I want to use the flow module from another module, this says the module flow does not export the package sends.flow. So if I want my module to be used by other people, which presumably I do because I created a module, I need to say what I export. So I'm going to export just that package. What that means is that the whole point about modularity is to allow you to encapsulate your code. So what I could have is if I'd had another package here, let's say new package. If I had an import package I didn't want you to access, then I don't export the import package and you can't do anything with it. You can't access it. So all of my internal details are hidden away from you. And that's the point of Jigsaw, really. Not just the spitting out your code, but hiding stuff that you don't want people to see. All right. So let's talk about the pain of moving specifically to Jigsaw. Some structural reorganization may be needed. Not as much as I originally thought. I didn't have to restructure everything to follow the JDK way of doing stuff. I could still continue to have modules in a Gradle-style structure, but I did have to do some structural reorganization. But that's largely because I hadn't been designing my application in a modular way to begin with, so it's kind of my own fault for not doing it right in the first place. This project has no command line build because I don't have Gradle. I had to take Gradle out. So everything is done through the IDE. All the dependencies are managed through the IDE. Running the tests is done through the IDE. So it's a super real-world application. I do want to try this in Maven to see if it works out properly. The IDE support for new functionality, specifically Jigsaw, but Java 9 stuff, is not quite as mature as it is for other stuff. So you could see that I could add modules into my module info file, but I can't generate my module info file. I couldn't generate the exports statement yet either. So this stuff is coming. We're working on it. We have issues for all of it. But for Jigsaw specifically, it's a good idea to understand what's going on under the covers so that you know what to do at sort of a raw level, because the IDE can't fix everything for you. And if you do want to use Jigsaw, if you do want to use modularity, you really do have to do your homework. I did a lot of brute force trying to figure out what my module files look like. Let me show you an example. So I didn't show you the others. Let's look at the client one. This module info, I brute forced my way through this. So I basically fixed all my compilation errors, the Java compiler will give you useful messages like you need to depend upon this module or you need to export that. So it does tell you what's wrong, but it just takes a while to brute force your way through that. Plus, some of the errors only come when you start at the runtime, not just at compile time. So don't do it my way, because it took about 2 days to do that. Run JDEPs and figure out how JDEPs works. I was really lazy. I couldn't figure out how to get JDEPs to work, so I was like, oh, how hard can it be? 2 days later, I wish I'd just figured out how to use JDEPs. So do read the manual. Otherwise, you'll be totally lost, especially this difference between module path and class path. That is actually what stopped me being able to run JDEPs, because I needed a module path, not a class path. The advantages, you do get a cleaner design. It is better design. It's better encapsulation, better separation of concerns. And you do get, I'm not sure deployables is a word, you can potentially make the code that you deploy, your jar files, smaller, which can be a good thing, particularly in the IoT world, maybe in cloud if you're like paying per byte, I don't know. But it can give you smaller code to deploy. For probably most applications, particularly enterprise applications that are kind of run on site, I do not think these benefits are worth the pain, certainly not straight away. The important thing to know, though, is you don't have to use Jigsaw to use Java 9. This is all optional. So if you don't use Jigsaw, you don't add module info, you're still using the class path, you're still working with jar files the way you used to, everything should work the way you expect it to. So don't go down the Jigsaw path just because you think you should, because you don't have to. And I don't recommend it either. Right, let's talk a bit about Reactive API. Oh, 20 minutes on Jigsaw. OK, fine. Let's talk a bit about the Reactive API. In Java world, or the JVM world, it's not just Java, we have had a Reactive Streams API for a little while, 1.0. And the Reactive Streams API has, most importantly, a publisher and a subscriber, and it's also got a processor, which is both of those things combined, and a subscription to help you manage your subscriptions. So there are lots of implementations of this, Akka, Reactor, RxJava, Vertex, a bunch of things like that. So if you're using a Reactive Streams library, most of them, like RxJava 2.0 onwards, will support the Reactive Streams API. Now, it turns out that the Java guys thought this was important enough to actually build it into their language. So the Reactive Streams API is part of Java 9. And it's not just part of Java 9, it's actually part of the Java.base module. So it's part of the free stuff you get. So it's kind of like, seems to be suggesting that the reactive programming is going to be, I was going to say the way to go, but like a standard way of working. At first glance, this looks exactly the same as the Reactive Streams API. It's not, of course. The package name is different. So java.util.concurrent.flow with inner interfaces, which match the same names as the interfaces. This is a bit of a pain, because when I was implementing this, I'm using RxJava and Reactor, and they use the Reactive Streams API, and I wanted my service stuff to talk in terms of the Java 9 Reactive API, and then I have to adapt between the two. So it's a bit of a pain. I'm not really sure how the library developers are going to manage that. I suspect maybe multi-release jar files might help, but I'm not sure. Anyway, be aware of that. It looks the same, it's not the same. Where do I use the Reactive Streams API? This is where we come back to our case study. So my services are really stupid. They use WebSockets to talk to each other, and they deal with strings. So I'm going to get a string in, and I'm going to put a string out, and I'm going to do stuff in the middle. And the stuff in the middle, because it was a Java 8 demo, the stuff in the middle effectively is a Lambda expression that maps a string to a string. So that's what I was doing. So I can do something a bit more powerful with Reactive Streams. So I can actually just say, well, let's assume that when I get stuff off the WebSocket, I can publish it, and people can subscribe to me to listen to that information. The business logic can now use the power of a reactive implementation to do something with that. And then I can have a subscriber which listens to the output of whatever the business logic does, and then put that back on the WebSocket. It's still the same functionality, but potentially can give me a lot more power. So I'll just take a quick look at how I implemented this. So look at the publisher to begin with. My publisher was a class called client endpoint. So I made this implement flow.publisher, which is the Java 9 Reactive Streams API. And this has a single method on it. subscribe. So a subscriber will subscribe to me. So I'm just going to implement that here. I get given a subscriber, and I've chosen in my service code to create my own reactive implementation. Don't recommend doing this, by the way, because other people have done this and done all the hard work. But all I really wanted to do was manage subscriptions. So I just basically create some subscriptions, have a list of subscriptions, and then when I get something off the WebSocket, I just tell all my subscribers about that. So my implementation is quite simple, so I can write my own implementation. I make it sound simple. That took ages to implement, of course, because everything always does. So on the other end, my subscriber end, I have broadcasting server endpoint, which the point is that anything can be, I can have a number of things listening to the WebSocket there, and this implements subscriber. The subscriber is a bit more complicated. I have an onSubscribe, which has a subscription, onNext, which is the main thing which does something. When I get something as a subscriber, when I get something, what do I do with it? OnError and onComplete. At the end of it, what do I do at the end? So my broadcasting server endpoint has onSubscribe. OnSubscribe, all I'm going to do is just say, give me everything you've got, just like everything, not just some set of values. OnNext is the main thing, so I'm just going to publish anything I get. I publish that on the WebSocket to anything that's listening to me. OnError. Do not do this. Because I was writing a demo, because I was learning stuff, I did stuff at the sort of simplest, quickest way possible. And I would like to call out that if you are working with reactive streams, the simplest, quickest way possible is not to do nothing on error. These are asynchronous messages, and so if something goes wrong, you have no idea. You don't get stack traces, it doesn't stop, it just doesn't do what you want it to do, and you've got no idea why. So this is not a quick way to learn reactive programming. Always do something with the error message, even if it's just print it to system out. And onComplete, close the WebSocket. So again, I've got a fairly simple implementation of this. I will come back to the error handling, obviously. So now that I've done that, where do I apply this? What's the point? What's the point in kind of changing my whole infrastructure to expose reactive streams, this Reactive Streams API? Well, let's look at one specific example of it. 15 minutes. I will never get this talk to under 50 minutes. Let's look at one example. What I had here, like I was saying before, one of the points of this demo is to demonstrate Java 8 streams. So I've got a lot of stuff with streams and Lambda expressions. What I could do, instead of using Java 8 streams for this, is use reactive streams. What this functionality does is I'm reading a file, and for every line in that file, I'm going to filter out some noise. I'm going to insert a delay of 100 milliseconds, because, thank you, Windows, for wanting to restart my computer. This is demo code, so I want the stuff that displays on the screen to not just get fired at the screen. I want a delay of 100 milliseconds so that you can see it ticking over. And then I'm going to publish that string. So we can do the same thing with reactive streams. I'll come back to that. I'm going to use RxJava for this particular implementation. So we have a flowable. So I need to add RxJava to the class path. And I need to, OK, fine, import the class. And then I need to add requires RxJava to my module info. That's my Java 9 overhead. So flowable from iterable. I'm going to do basically the same sort of thing I could do before, but I don't get the nice try with resources functionality because it's not quite as straightforward, but we'll do something similar. And then I can reuse all of that. Peak in Java 8 will do some operation on everything which comes through the pipeline at that stage. In RxJava, I can say do on next instead. It's the same functionality, basically. So I can use RxJava to do exactly the same thing that I was using Java 8 streams to do. Let's get rid of the Java 8 version. So now I've got slightly more code that's not quite as pretty, and I depend upon an external library to do exactly the same thing. But I'll show you why this might be an advantage. I was always uncomfortable with this kind of like, use the kind of the debug peak method to like inject 100 millisecond delay. But it's actually part of the business logic of my application. I want each line in the file, I want it to be delayed by 100 milliseconds. With reactive streams, you can do this in a slightly different way. So I can say flowable interval, give it an interval of 100 milliseconds. Let's call it tick. So this is a stream which is just going to tick every 100 milliseconds. It's going to emit a long value every 100 milliseconds. Now what I can do, instead of inserting this delay here, I can zip my stream of strings from the file to my stream of ticks at an interval. And then I have to say, well, given I have a string from this stream and a long from this stream, what do you want me to do with those two values? Well, I don't care about the long. I just want the string value. And then I can get rid of this. And so that's quite a nice way of having the same functionality. And it also demonstrates something very different about reactive streams versus Java 8 streams. You can actually merge two streams together. You can use two streams at the same time. You can also do things like you can reuse streams. In Java 8 streams, when you've done for each, then this stream is done, and you can't do anything else with it. But with reactive streams, if I have this as a stream in its own right, I can do other stuff with this stream. And I can reuse it. So I can split streams, and I can merge streams, and I can reuse streams, which I can't do in Java 8. I have another implementation as well, which uses Reactor, but it's basically the same thing. It shows that you have a syntax which is very similar to Java 8, but the functionality is slightly different. In this other case, I'm using flatmap, and flatmap in reactive streams has a very different concurrency model to flatmap in Java 8 streams, and it's something to really be aware of, because it doesn't work if you think that it just works in a single-threaded way. OK, so just to summarize the reactive side of things, I told you I was going to give you a really quick demo of reactive. Java 8 streams and reactive streams look pretty much identical. The syntax is very similar, but they're not the same thing, and they don't work the same way. So reactive streams, you can work with multiple streams, you can zip them, you can split them, you can have multiple consumers. Back pressure is a very, very important part of reactive streams, and this is a good thing. You treat back pressure as being like a first-class thing to consider. Like, what do I do if the producer is producing more than the consumer can consume? Do I drop messages? Do I block? Do I send a message to the user saying, stop pressing that button so much? I mean, what do I do under the case where when I have back pressure? It has a very different concurrency model. There's like threading going on underneath the covers sometimes that you're not aware of, whereas Java 8 streams are single-threaded unless you tell them to be parallel. But the point about the Java 9 Reactive API is that you can expose the Reactive API and use whichever implementation you want to under the covers. So in this case, I used RxJava and Reactor. I could even be using different JVM languages, but they're still talking in the same API. So that's a really good benefit. All right. Oh, good. I've got 10 minutes for other Java 9 features. This is fine. There weren't many of them. I think the most used Java 9 feature is going to be this, convenience factory methods for collections. And I'll show you why. Let's take a look. In the olden days, i.e. now, when we want to create a new list, we say arrays.asList. In the new world order, I can say list of. I've just saved myself 6 characters, yay! And the implementation of list is slightly different. It is an immutable list, but I believe arrays.asList gives you an immutable list anyway. It's just a slightly different type of immutable list. So that's great, most used feature. No, let me show you why it's interesting. Let's pretend that we have a set instead. Now, currently, if you want to create a set, like the most succinct way of doing it is to create a list and then put it in a hash set and then put it in a set. Now, of course, we don't have to do that anymore. Ta-da! And that's an immutable collection as well. So this is a good thing. And of course, you can make this narrower. Just get rid of that. And then at some point in the near future, like Java 11, you might be able to say that. Ta-da! Okay, probably not for a constant, maybe for like a variable. But so you can see how we start to get rid of some of the boilerplate that everyone's always moaning about in Java. The other place this is really interesting, particularly because I used to work for MongoDB and we used to create a lot of maps, is this is code that existed in this application. I needed to initialize a map this way. And this is in the production code, not in the test code. And it's not uncommon to see this, and it's ugly and horrible, but it was the only way I had to do it. But not anymore. I could say map of entries. I can use my very favorite column selection mode. Map.entry. I can use the most used feature of IntelliJ IDEA. Replace. Oh, wait, no, I need to replace it with that. And so now this is how I create my maps. It's a bit smaller. It's not like loads smaller, but it is a bit smaller, a bit more succinct. What's really nice about it is if you've got fewer than 10, oops, let's get rid of column select. If you've got fewer than 10, you can say map of, and you can get rid of all of this. What happened to column select? Oh, IntelliJ, don't let me down now. Oh, you hate me so much. Fine. Let's use the most used feature. I told you it's an EAP. Also, I'm using a surface. Go away. Right, so, and then I can just give key value pairs if there's fewer than 10. So you can see I've got key 9 there. So that's quite nice. So this would have been super useful when I was working at MongoDB 3 years ago, and it's still not out yet in Java 9. But it's not quite as pretty as perhaps the groovy way of creating maps, but it is an enormous step in the right direction. So working with collections is just going to be an awful lot easier in Java 9. And honestly, this is the thing I think I'm going to use most from Java 9, more than anything else. The poor Oracle developers, they worked really hard on Java 9 for 7 years, and I'm like, oh, I really like your collection methods. It's great. Do you use Jigsaw? No, don't be silly. Right. Private methods on interfaces. This might seem really stupid, because what is the point of having an interface which defines your API and then having a private method on there? Now, let me show you. Again, this is real code, which was actually in my application, and I had to have duplicate code without being able to extract it into a reusable method, because in Java 8, as you know, you can have static methods on interfaces and default methods on interfaces. So interfaces don't just define the method signature, they actually have behavior in them. So you could, potentially in Java 8, have duplicate code. I could, of course, have extracted this into a method, get value for field. Let's move that down. But I didn't want this to be part of my interface, so I don't want this to be a public method. And in Java 9, it doesn't have to be. OK? So it's super useful for static methods and for default methods. Otherwise, it's really stupid to have a private method on an interface. And this is part of a bigger JEP called Milling Project Coin. And there's loads of little bits and pieces in this about better ways of working with generics and anonymous inner classes and some other things which just tightens up some of the syntax. New methods on the Streams API. So Java 8 Streams can have, let's turn this back into a Java 8 Streams thing. Revert. What about this as well? Java 8 streams. Java 8 streams can be infinite streams, the same as reactive streams are designed to be infinite streams. Java 8 streams can be infinite streams. I do not recommend this, as it's very difficult to terminate streams in Java 8. Like, it's very difficult to say, I'm done now, please, like, let's get over it. Now in Java 9, there is a way of saying take while. So take while some predicate is true. So let's assume that our file of tweets, let's say it was ordered and each string started with like a number. So let's say I want to take the first, anything which begins with 1 through 5, then I could say s dot starts with, so I'm going to take while it doesn't begin with 6. And then when I get to the first entry, which begins with 6, I just stop the stream and I terminate it. I could potentially combine this with drop while, and I can say s dot starts with, I don't know, 2. So I can take everything from like 3 through 5. So this is going to be, I think this could be really useful if you're working with infinite streams. It's particularly useful if you're working with ordered streams, obviously, because you want to be able to say, like, ignore the first set of values and ignore the last set of values. You can use it to cheat and do some other stuff. So I had a running field. So running equals true. And then I can set running equals false when I actually want it to be false. And then my stream will terminate. So I can do that. Also, it should be an atomic Boolean because it's multi-threaded and blah. But you get the idea. It's possible to terminate things with external criteria as well. So that's really useful, and in my opinion, should have been there from the beginning. But you know, these things are difficult to do. And stack walking API. Everyone knows that creating or getting a stack trace is quite expensive, right? But now we can do things in a more lazy way now that we have things like lambdas and streams and stuff, so that we don't have to get the whole stack trace and then do something with it. We can kind of build it in a lazy way. I don't know all of the ins and outs of it, but I've only played with it a little bit. But what you do is you get a stack walker, and then you end up with a slightly complicated syntax, a stack frame stream, which is a real stream. I'll put this down here. So I can do the sorts of operations I expect to be able to do. So I want to filter it. So I could say, I don't know, I want to filter out anything where my stack frame starts, stack frame get class name starts with, I don't know, like my package name. And then maybe I want to do something like count how many instances of my classes are in that stack frame. I'm not sure exactly what you might want to do, but the point is that you can, that's not what I wanted to do. So you can do things like you can basically do queries on the stack frame as it is, and it's not as expensive as it was before. Of course, if you do for each, then it's as expensive as getting the stack frame to begin with. But it's quite an interesting thing, and it doesn't have to be in an error message. It could be at any point in your code. So if you're doing lower level stuff, you might want to figure out where you are, what happened, and so forth. Multi-release jar files. This is like a big topic in its own right. I had a bit of a play with this. From now on, potentially, a library might give you a single jar file, which is for both Java 9 and pre-Java 9 versions, just in a single jar file. So you know that at the moment, if you're using Java 8, some of your libraries might say, use this version for Java 8 and use this version for pre-Java 8. Well, from now on, the jar file itself will have Java 9 specific code if you're running on Java 9. Otherwise, it will use the Java 8 and before code. Note that this only works Java 9 pre-Java 9. You can't do the Java 8 version and a Java 9 version, which is kind of sad. But going forward, you'll be able to have a Java 9 version, a Java 10 version, Java 11 version. So this is kind of cool. I haven't seen anyone using it yet. I had a bit of a play. It's not impossible to work with. There are some best practice ideas that the API should be the same between the different versions. So I'm not sure if this is a solution to the reactive streams API problem or not, but it's potentially there. Process API updates. I'm kind of really out of time, so I'm just going to give a quick show of what this looks like. The main thing here is that you can get your own PID. So you can get your process ID now, which is quite cool. Now, I think that's the most useful thing here. There's loads of other stuff around being able to build up command line stuff, and that's great. But I think probably the most useful thing is the ability to get your own PID. Updated deprecation. This is kind of cool. This is all cool, otherwise I wouldn't have put it in here. Thread, here we go. Now, when you see deprecated methods, they can also be annotated with when they were deprecated, so Java 1.2, and whether they're going away or not. Okay? So that's kind of cool. So you can get an idea of, is this deprecated, and oh, you shouldn't really use it, or this is deprecated, and if you don't stop using it, it will go away and your code will break. So this is really useful for when we're looking at other library code. If you're working on library code of your own, then do start using this, because it's super useful for your users. What else? I keep moving the slides on so fast that he can't take photos. I feel really sorry. You can generate HTML5 Javadoc. Yay! We brought Javadoc into the 21st century, only 17 years too late. This is great. If you generate Javadoc, of course, this is kind of useful to know. Mostly, we will be reading Javadoc, so it's kind of nice to know that our Javadoc won't be quite as ugly. Most importantly, this allows us to have a Javadoc search. Look. And it's got type ahead as well. So when you start typing in there, it says, oh, do you mean, I don't know, java.util. whatever. And this is the actual Java 9 Javadoc. And I've been using the search feature on here, and it's super useful. It's really cool. Oh, what a shame. I don't have time to talk about the REPL. If you're interested in the REPL, there's a tutorial here. It tells you how to get started. It tells you the sorts of things that you can do from the REPL. If you have used a REPL before and you kind of know what you want to do with a REPL, and particularly how you want it to integrate with the IDE, do tell us how you want IntelliJ IDEA to integrate with the REPL, because we haven't done it yet, and we really do want to know use cases from you guys. OK, in summary, I'm sorry, I made you late for lunch. The pain of Java 9. Your code might break. So my recommendation is do download an early access of Java 9. Do try it out now. Figure out which things break, because it's probably not your code. It might be your infrastructure. It might be your CI server. It might be Gradle. It might be something else. It might be a library that you're dependent upon. For this demo, I had to migrate from Mockito 2.7.8 to Mockito 2.8.9, because it was dependent upon a library called ByteBuddy, which wasn't working with Jigsaw with the version that I was using. So download it and see what's going to stop working. It's probably not your code. It's probably something else. And then the important thing here is that if you find a library that isn't working with it, or you find a tool that isn't working with it, do tell the library maintainers or the tool vendor, because we don't always know what weird things you're doing in your system, and we need to know how the pain that you're feeling so that we can fix it. It sounds unfair to put the work onto you guys, but when I worked at Mongo, this library, it's like 100 classes. It's this tiny library, including tests. But people were using it in all sorts of odd ways, and there's no way that we can test it in like 1 million different environments. It's just not possible. The reason why your code might break is that there's a lot of stuff that's going away. Deprecated stuff is being deleted in Java 9. Woohoo! There's a lot of stuff sort of at the command line, so garbage collection, flags, launch time JRE version selection, which I'm not sure I've ever used. But lots of things that you can use at the command line has just basically gone away. Encapsulate most internal APIs. That's the thing where sun.misc. whatever, they all go away. So it says encapsulate, which sounds nice. What it means is it's gone away, you can't get to it, and your codes are going to break. And they've removed a bunch of stuff that you probably weren't using anyway. Oh yeah, deprecate the applet API. Someone asked me on Monday, what's the replacement for applet? HTML? I'm not sure. There will be some unexpected behavior, I believe. So there's things here. These are the sorts of things that, these are the sorts of changes that people make thinking, oh, that won't impact anybody. And it'll turn out that somebody somewhere is doing something weird, like looking at the GC log files and like parsing the string values to get particular errors to figure out what went wrong. And they've changed a lot of the logging. So they've changed including some of the log messages and stuff. So some of that stuff might impact odd things that you were doing. For me, the number one thing here, I think, well, another thing is that G1 is now the default garbage collector. I don't think that's a big deal, because I think if you care about garbage collection, you've probably tuned your system to within an inch of its life, and you don't care about the defaults. And if you don't care about the garbage collector, you're using the defaults, and you don't care. So I think it's not a problem, but be aware of it. The one thing which I think is going to bite people on the arse and not realize it is new version string scheme. Java 9 is officially Java 9, not Java 1.9, like Java 8 was Java 1.8. And when you get the version string, it comes back as 9. And you'll see that some of the tools that you use, including earlier versions of Gradle and earlier versions, I think, of IntelliJ, will tell you, I have no idea what this version 9 is. Or it might tell you they've got an array out of index exception as it tries to do 1 point something, and it's not there. So I think this is going to bite way more people than anyone realizes, so be aware of it. If you are doing any version string parsing in your application, it's not going to work in Java 9. Java 9 is still evolving. It's still evolving even now. Like, we're in June, it was supposed to be released next month, and the API is still changing. Jigsaw is still changing a lot, mostly for the better. Those module info files that I showed you, when I first did this application, which was only February, March, they were massive. I had to define like every single package I was using. And now they're much, much smaller and much easier to manage. So it's still evolving, it's still getting better. IntelliJ IDEA is also still evolving. And we need your help. Us and the Oracle guys on the JDK and the library developers need the help of real developers to tell us what pain you're feeling or what features you want to see to help us give you what you need. Java 9, I've actually raised like 2 or 3 bugs on Java 9. I thought I was being stupid and I broke something, but it turns out I was doing something fairly ordinary, but that hadn't been expected. So I've raised bugs on the JDK, and the JDK has changed accordingly. So there's still time to do that now. Better to do it now than before it's actually officially released. It's worth it. Don't rush into modularization. You don't have to use Jigsaw to use Java 9, and I don't recommend modularizing your code unless you have to. For new applications, I think it's a good idea to think in a modular way, because I think your design will be simpler and cleaner, and it's kind of the way forward. But if you're working in a fairly mature application, I would not recommend making major changes like modularizing your code. It's the same as deciding to migrate your monolith to microservices just for shits and giggles, which we've all done, let's be fair. So yeah, it might not be for you. Do be aware that it's not a trivial thing. Reactive streams are not the same as Java 8 streams. They look the same, but they have different behavior, and they're designed for different use cases. The gain. Jigsaw in particular encourages good design, encapsulation, separation of concerns. That's great. Java 9 encourages new ways of working, particularly via the REPL, via reactive streams, and things like that. So that's good. It's moving us forward. It's helping us to evolve. For me, it's not like the most compelling tagline. Java 9, just a bit nicer to write code. But that's actually the most compelling thing. It will be easier for us to create collections. There will be slightly less boilerplate. It will be things like being able to get the PIDs for our processes and stuff. I think these things will just make our life a little bit easier. All the slides, all the resources, all the links to where to download Java 9, all the links to pretty much everything is available from this link, this URL here. So please do take a look, and because I don't have any time for questions, terribly sorry. Thank you very much.